Intro. Homo sapiens, or modern humans as we know ourselves, have been on this planet for over 200,000 years. We have built civilizations, destroyed them, and today have created over 6,500 different languages. Many of these languages, along with the civilizations that nurtured them, have been erased from the stage of history. Today, a technology also created by human hands is helping us understand ancient and dead languages around the world. Artificial intelligence. Get ready to discover 20 ancient languages deciphered by AI, from 50,000-year-old tablets to the most mysterious book in history. Cuneiform deciphered by AI. 5,000 years ago, in the heart of ancient Mesopotamia, scribes immortalized humanity's oldest written records in cuneiform, carving wedge-shaped symbols into wet clay tablets. These tablets have long challenged scientists, as only a small fraction of the more than 500,000 that have survived to this day could be translated. But with artificial intelligence, everything changed. A groundbreaking AI model developed by researchers has taken a major step forward in deciphering these ancient texts. Cuneiform is a difficult language to read because a single symbol can have multiple sounds or meanings depending on the context. Moreover, many of the tablets we have are damaged or fragmented, making the puzzle even more difficult. However, researchers have managed to develop an AI model that can translate cuneiform directly into English and even fill in the missing pieces of broken tablets by predicting what the original text might have been. Last year, AI helped us decipher and decode 50,000-year-old royal decrees and other writings. AI decodes Ugaritic language. Jing Luo has been fascinated by the world's forgotten and dead languages since a young age. When she became a computer science doctoral student at MIT in 2015, she decided to pursue this long-standing interest with her advisor. As Luo and her advisor sought a way to understand and revive lost languages, among the writing systems she sought to decipher was the ancient Ugaritic language, used around 1300 BC. Scientists have long linked this language to early Hebrew, but despite years of research, the mystery of this language remained unsolved. Luo and a team led by Professor Regina Beret developed a neural machine translation model that can decipher the Ugaritic language with remarkable accuracy. Ugaritic is difficult to decipher because there are no clear spaces between words, and many symbols can have multiple meanings depending on the context. Traditional methods required experts to manually piece together these texts for years. However, Luo's AI model works by recognizing patterns in the ancient language and matching them to known languages like Hebrew. This model uses the minimum cost flow approach, where the AI looks for the most efficient way to decipher characters by comparing them to what we know about other ancient languages. It not only deciphers words but also reveals semantic relationships, giving scientists clues as to how the Ugaritic language might have been used in everyday life. The Vesuvius Challenge. In 2023, the Vesuvius Challenge, a global competition, was held to decipher charred scrolls unearthed from sites devastated by Mount Vesuvius. The first winner was 21-year-old Luke Farret, who achieved something incredible. He became the first person to read a portion of a scroll that had been buried in the eruption of Mount Vesuvius for over 200 years. The scrolls found around Mount Vesuvius are so charred by volcanic heat that they look more like burnt logs than manuscripts and crumble to dust at the slightest touch. However, thanks to artificial intelligence, Farret deciphered a word from the ancient text that means purple. He developed an algorithm that detects tiny crack patterns in the scroll structure that correspond to the ancient ink. This ingenious method allowed him to identify the first word on the scroll and win $40,000. Today, it is believed that this burnt paper comes from a library in a villa that may have belonged to Julius Caesar's father-in-law. Scientists believe thousands more scrolls are waiting to be unearthed, potentially containing lost works of philosophy, history, or literature. Google AI deciphers hieroglyphics. Google is a leader in many fields, including artificial intelligence research. Recently, Google developed and introduced Fabricius, an AI-powered tool that is changing the way we understand ancient Egyptian hieroglyphs. Launched by Google Arts and Culture in collaboration with experts from Macquarie University, Ubisoft, and Cycle Interactive, Fabricius is designed to help researchers and the general public easily understand hieroglyphs. Fabricius uses machine learning to break down the 1,000 different characters that make up hieroglyphic writing, used by ancient Egyptians for thousands of years. The tool has three main modes: learn, play, and work. In learn mode, users can explore the history of hieroglyphs and practice drawing symbols, which are analyzed for accuracy by AI. Play mode allows users to write their own messages and convert them into hieroglyphs, almost like ancient emojis. In work mode, scientists can upload images of hieroglyphs and decipher them through AI, speeding up what was once a manual task that took years. Fabricius is the first digital tool to use AI to decipher hieroglyphs. Previously, Egyptologists meticulously examined books to translate these ancient symbols. Now, Fabricius offers a faster and more efficient way to analyze and understand these inscriptions, helping scientists decipher texts from the ancient world faster than ever before. The best part is that this tool is open source, allowing it to evolve and improve with contributions from the global research community. Linear B and AI. In 1900, British archaeologist Sir Arthur Evans, visiting the Palace of Knossos in Crete, came across a mysterious writing system now known as Linear B. Despite years of research, Evans was unable to decipher it, and even after his death, the script remained a mystery until 1953, when British architect and self-taught linguist Michael Ventris finally cracked the code. Ventris's success was based on the groundwork of Alice Kober, a brilliant classicist who meticulously analyzed the structure of the writing. Kober was the first to suggest that the writing was inflected, meaning words were made up of roots and suffixes. This was a crucial step. She spent years identifying patterns and connections in the Linear B signs, cataloging some 200,000 note cards, paving the way for Ventris. Ventris made his historic discovery by realizing that some words on the tablets corresponded to place names in later classical Greek. This allowed him to match syllables and phonetic values, revealing that Linear B was an early form of Greek. Today, a team of researchers from MIT and Google Brain has developed a machine learning algorithm that can automatically translate Linear B with impressive accuracy. The AI identifies cognates or words with a common origin and uses known Greek language structures to translate Linear B. The system achieved an accuracy of about 67.3% in translating the writing into modern Greek, a significant improvement over previous manual methods. Linear A, the next challenge. If there is a Linear B, there is of course a Linear A. Linear A is a written script used by the Minoans on the island of Crete, predating Linear B. Despite its similarity to Linear B, Linear A remains undeciphered, as the language it encodes is unknown. However, recent advances in artificial intelligence are giving researchers hope. Institutions like MIT and Google DeepMind are using AI to analyze Linear A. By training neural networks on known writing systems like Linear B and other ancient languages, these systems can identify patterns and relationships between symbols that may have been missed by humans. AI's ability to process large amounts of data quickly has already led to breakthroughs, especially in understanding numerical systems and some common signs in Linear A. As AI continues to evolve, many hope this technology will eventually crack the code of Linear A as well. Here is the text reformatted into paragraphs without missing or skipping any words. AI deciphers broken Greek texts better than humans. There are many things we fear AI will surpass us in, and perhaps deciphering and decoding languages should be at the top of the list. Google's DeepMind AI, Ithaca, is revolutionizing the way we decipher damaged ancient Greek texts, and it's doing it better than humans. Named after Odysseus's homeland in Homer's Odyssey, Ithaca was developed to restore fragmented inscriptions that are thousands of years old. Many Greek texts are derived from damaged, incomplete, and fragmented books or tablets from centuries past. This makes it difficult to restore the texts manually, at least for humans. But for AI, reconstructing these texts is a breeze. By training Ithaca on over 60,000 ancient Greek inscriptions, feeding it letter and word patterns along with the age and geographical origin of the text, researchers have managed to create an AI model that can easily predict and read broken Greek. Ithaca's AI model can now fill in missing gaps with an impressive 62% accuracy, far outperforming human historians, who only achieve 25% accuracy on their own. When combined with human expertise, this accuracy increases to 72%. This ultimately means that humans and AI still need to work hand in hand. AI helps unlock the secrets of the Etruscan language. The Etruscans were a people who dominated central Italy long before the rise of Rome. They are one of the most mysterious groups in history. Although they left behind many works written in their language, we know very little about what they wrote. This is because Etruscan does not have much surviving text and does not appear to be closely related to any known language. A new initiative, led by teams using neural machine translation models similar to those that help decipher ancient scripts like Linear B, is trying to break through the barriers of Etruscan. These AI models are being trained to recognize linguistic patterns in missing or fragmented texts, helping researchers predict missing words or symbols and compare them to other languages from the same period. It is hoped that these algorithms, capable of processing massive data sets of ancient inscriptions, will help identify grammatical structures and vocabulary in Etruscan writings. Today, AI tools are being used to analyze a 2,500-year-old stele discovered near Florence. With the help of AI, we may finally learn more about one of the most mysterious ancient peoples in Europe. AI can translate dead languages in seconds. Akkadian. Maybe you've heard of this language before. After all, it is one of the oldest languages in the world, and also one of the most difficult. Spoken in ancient Mesopotamia, Akkadian was written in cuneiform, wedge-shaped symbols pressed into clay tablets. We have a lot of untranslated texts, but there are a limited number of people who can read Akkadian. With AI, this will no longer be a problem. For centuries, Akkadian had to be painstakingly transliterated, that is, converted into Latin characters, before being translated into English. But with a new AI model, we can now skip most of this labor-intensive process. Think of this model as a Google Translate for dead languages. What's amazing is that it achieved an impressive 97% accuracy when translating into Latin transliteration and also performed well when translating directly into English. However, it sometimes produces incorrect results and struggles with literary or more creative texts. Still, when used in conjunction with scientists, this AI will be instrumental in helping us understand the Akkadian writings left behind.